Hi everyone, so in this video I want to start with exception handling, and although this is a more code intensive thing, I just wanted to do a theory session to let you know what exceptions are and how we are going to go about writing the code for this. So exceptions are basically events which disrupt the natural flow of the program, and there are a lot of different exceptions. There are different types of exceptions. So one of them is the null pointer exception, and you may actually have come across this pretty often, I think. So let's say you try to make something like an object O, and you forget to use the new keyword. So although you've made an object, you haven't initialized it to anything, so O still contains null. And if you try to use O somewhere, that's one kind of exception. Another kind of exception is the array index out of bounds, which is which basically just means that you're trying to access an element that's beyond the size of the array. So let's say you have a 5 element array and you try to access the sixth element. That's an array out of bounds, array index out of bounds exception. And this is actually different from how C++ work, because those don't check for array bounds. They just let you access the sixth element if you have the rights to access it. And another kind of exception is an arithmetic exception. So an arithmetic exception is basically something which some math that you're trying to do which isn't valid. For example, you're trying division by 0 or something like that. So these are different types of exceptions, and there are a lot more. Um, so how do we actually go about handling exceptions? Actually, before that, what happens if an exception occurs in a program? So what happens is, let's say you have something like a function main. So this is your main right here. Um, and from this you're calling another function which is, let's say, foo, and inside of this foo you have some arithmetic which, or some exception that happens within foo. What this foo does is it tells the Java virtual machine. So the Java virtual machine is where all the Java programs run. So this foo says that I have an exception, and it tells the JVM. And what the JVM does is it goes back, so it goes in the reverse order. It goes from foo to main, and it gives you something called a stack trace or a call stack. So what it does is, after it stops the program, it gives you uh, something like the line number inside of foo where the exception has occurred, and also the line number in main where we have called foo. So that's what the JVM does. And however, it does terminate the program, and there are a lot of cases where we may not want to stop the program. So let's say you're making a calculator and a user tries some division by 0. You may just want to tell him that you tried a division by 0, and that's invalid, please enter a different set of numbers. So the way we handle exceptions is we use something called a try block and something called a catch block. So what we tell the program is, let's say we have two variables a and b, which the user has entered. So what we tell the program is something like try a by b, and if you can't do this, there'll be an exception. So catch, and you'd want an exception here, and in this case it would be an arithmetic exception. So arithmetic exception, and you'll have to name this object something. So arithmetic exception e, let's say. And within this catch block you may want to say, you may want to print out something. You may want to do a system.out.println, and after you've done that, what happens is it tries doing a by b. If b is 0, it goes to the catch block, and then it does whatever is inside the catch block. So you may have guessed from this right here that at the end exceptions are just objects. So exception is actually a class, and arithmetic exception is a class that inherits from the exception class. So all of these null pointer exception, array index out of bounds exception, all of these inherit from the exception class. And basically how it works is there's something called a throwable, um, which is the top class, and the exception class inherits from this class. um, and there are actually two types of exceptions. There are checked exceptions and there are unchecked exceptions. So what these mean is that checked exceptions are basically uh, something that the program forces you to handle, uh, and unchecked exceptions are something that you may or may not handle. So these are two types of exceptions. And there's another very important block that is often used with the try and catch block, which is the finally block. So the finally block is really useful when you want to do something irrespective of whether the program went through the try block or the catch block. So the try block and catch block actually always go together. You won't have one without the other. If you try to, you'll actually get an error which says that uh, there's a try block without a corresponding catch block. So what happens is the program is going to go either through the try block or through the catch block. So if it encounters an exception in the try block, it'll immediately switch to the catch block. And one example where you may really want to use the finally block is something like this. Let's say you have a file and you try to uh, do something like open the file. So you do file open, and then you try to do something like write to this file. And what happens is the opening of the file itself can throw an exception, um, and writing to a file can also throw an exception. So let's just assume for now that opening the file was actually successful, but you were unable to write to the file, probably because it's read only, you don't have the permissions, whatever reason. You were unable to write to the file. So at this point, it'll switch to the catch block. So this is within your try block, and within the catch block you do something like this. um, you say that whatever operation was could not be performed, and now what you have is you have a file open and you were unable to write to it. So irrespective of whether you were able to write to it or not, so irrespective of whether this line right here threw an exception or not, you may want to close the file. So that's where the finally block comes into the picture. So within the finally block you may want to say file close. So that closes the file, the program closes the file. So that's when the finally block is really useful. And as far as functions are concerned, they would go to the finally block even if you try to return from within a try or a catch block. So the finally block is always executed, and the only way to stop a finally block from executing is to terminate the Java virtual machine itself. We do that using system.exit, and if you do that, that's the only case where the finally block is actually skipped. So that's what the finally block does. And there are also two more very important keywords here. One of them is the throw keyword. So what if I have a function, let's say foo, which does whatever operations it does, and it's likely to throw an exception, and we don't really want to handle the exception there. We just want to throw it back to whoever called foo, and we want that function or that method to handle the exception. You don't want to bother about handling the exception inside of foo. In that case, you can actually throw an exception manually. So you can just say something like throw exception, or you can just say throw something like arithmetic exception, or throw uh, null pointer exception, or whatever. uh, there actually needs to be a new keyword right here, so throw new exception, and then a parenthesis. This actually creates a new object or a new instance of the exception class, and that's what gets thrown. So this is how we can do it. Or you can also just if you have an object like we had e inside the catch block, we could just throw that object itself. So in that case it will just be throw e. And the other keyword that's really important is the throws keyword. And the throws keyword is useful when indicating that some method is going to throw an exception. So when we actually do whatever public void foo, we actually need to say that um, it throws exception or arithmetic exception, null pointer exception, whatever. So null pointer exception, um, or it could throw something like an arithmetic exception. And we could also have a method that throws more than one exception. We just need to separate those with a comma. So that's what the throws keyword does. And I think this is it about the theory that you need to know, all the keywords that you need to know to do exception handling. I'll do a programming session on it, so I'll see you there.